All right, hi everyone. Today is February 1st. So today we will finish 1.3 and start 1.4. Your homework 2 about P.5, 1.1, 2.1 is going to do this Friday. Okay, let's look at your homework 1. So your homework 1, okay, this is a sample homework. So this is what I want you to do. Use pencil to finish your work, and then once you click the solution, use red pen or other color pen. If you are correct, put a check mark on that problem. If you have mistake, pause it and write a correction next to it. So this is perfect. This is what I want you to do. Okay, everybody? Then let's see. Okay. So for some of you, you forget to put a check mark. If you don't put a check mark, I don't know whether you have checked the problems. So every problem, if you have checked it, put a check mark so I know. Okay? And yeah, if you make a mistake, write the mistake, circle the mistake, and write the correction next to it. And so the first homework, if you get 10 points, that's good. If you don't get 10 points, you can resubmit to gain the 2 points back. Okay, everybody? So I know maybe the first time you don't know the requirements, so I give you a chance. You can resubmit to gain those points back. And please submit one PDF with all pages on it. Okay, so one PDF, not image, not Word documents. And please rotate your picture. So I can see it better. Okay, so I'm gonna put my laptop. So please rotate your pictures. Okay, and submit one PDF. Okay, and then yeah, see here you circle your answer. I don't know, did you check it or not? Because some of you finish your work, you circle your final answer, but I don't know whether you have checked it. So circle just means that's your final answer. It doesn't mean you have checked it for me. Is it clear, everybody? So please check it. And here, I know you have checked it, but you put a cross. Then where's the mistake? Where's the corrections? Okay? So if it's wrong, write down the corrections. Do you have other color pen? If you don't, come to my office. I can give you a red pen. Okay? Yes. And then here, yeah, so you circle your answer. Does that mean you have checked it? Okay. And submit one PDF with all pages on it. Okay? So you can use some cell phone app like Cam Scanner, or you can send your email to send the pictures to you, and then you use your laptop to download the picture, and then use Word documents or Google documents to copy the pictures and paste, then save as a PDF. Okay, everybody? All right. So yeah, I don't see any red color mark. Okay. So leave some space. Okay. When you finish one problem, leave some space because you might have mistake, right? Then you leave some space to write down the corrections. Then before the exam, you can review your homework and see what mistake you have made, and then remind yourself, don't make this mistake again in the exams. We learn from our mistakes. Okay, everybody? And then, yes, so here is another example. The student write down the corrections, but for some other problem, I don't see any check mark. So I don't know whether you have checked the other problems or just this problems. Okay, so please, if you're correct, put a check mark. Okay, and please zoom in and zoom out so one page of your picture fit in one page of the PDF. So look at this. This is one page. Okay, this is using the cam scanner. This is one page, and then you see the picture is zooming so big, so I cannot see the part C, right? So this picture zooms back. Okay, so it fits in the one. And then here, this is one page, and there's so many pictures on one page. It's hard to see what's on it. Okay, so zoom in, zoom out. So one picture is fit in one page. So your PDF might have 4 or 5 pages. It depends on how many pages of pictures you have. Okay, so that is the requirements of your homework. Okay, I hope from now on you all can get perfect score on your homework. Okay, so actually I prefer your homework has a lot of red color corrections because then we can learn from it. Please be honest, okay, to yourself. Once you click the solution, please use red pen, okay? Don't use the pencil and get a perfect homework. I can tell you, even though I don't get perfect homework. So when I write down the correct solutions, sometimes I make mistakes too. Yes, we're all human beings. We make mistakes. It's okay. This is math. If you make a mistake, maybe just get a new piece of paper and then redo the problem. So it's still okay, right? Unlike chemistry, where you do some experiment, if you prove something by mistake, it might explode. But for math, we're safe. It's okay to make mistakes. Okay. All right. So that is the sample homework. And then this Friday, you're going to submit homework 2. Okay? By the way, so my office hours is Monday, Wednesday, Friday, 1 to 1:50, 3:15 to 4:15, and Tuesday, Thursday, 11 to 12. Or by appointments. If you cannot come during this time, you can send me an email and we can have appointments. We can only meet in the evening. Yeah, we can also meet in the evening. Then we can meet virtually. Okay, so we can go to TED Live. You know how to go to TED Live. Last time we were our snow class. We don't come in person, so we can join the TED Live together and then we can talk. Okay. And also, here, this is share your questions with Suki. Okay, so what is something you don't understand in today's class? Okay, you can write it down. And what concept are you confused about? You can write it down. Okay, so if you don't want me to know your name, because if you email me, I know who you are, right? But if you don't want me to know your name, you still want to ask me questions, you can put your questions here. Okay, when I see it, I can answer it. Okay, everybody? And we also have the tutor available in OSS. Yeah, they have a lot of math tutors. So do all you can to improve. How many of you want to get an A in this course? Everybody, right? So let's try our best. Okay, so let's see. Yes, 1.3. Last time we talked about how to solve. Let me make sure my microphone is on. Yes, it is. Okay, good. Yeah, last time we talked about how to solve equations. But when we have rational expressions, which means the denominator has the variable x, in this case, you gotta be careful. You need to look at the domain. Domain is the possible x values such that the expression makes sense, right? Denominator cannot be 0. So x cannot be those two numbers. Let's see. X cannot be those two numbers. Thank you. And then we find the common denominator, and then we multiply by something to create all the common denominator. Then we both sides multiply by this common denominator to clear the denominator. And then we continue and solve for x. At the end, you have to check. Is this x value in the domain? If it's in the domain, then it is a solution. But if it's outside of the domain, see, x cannot be -2. Therefore, this number cannot be a solution. We have no solution for this problem. Okay, everybody? So extra steps. You need to check your work. Okay. So we will talk about more in session 1.4, which is the handout today. And then last time, we also did some examples. Okay, you can set x be the variable. Okay, or you don't if you don't want to set the x, you can just do it directly. Okay, remember this problem? You can subtract 500 and divide it by 24. You still get the same answers. Okay, everybody? By the way, if you go to our course website, so this is the blank notes, okay? And then the two February 2nd, February 4th is my previous semester recordings, okay? And then this is the notes with answers. This semester's recording is in the Blackboard, right? So is in the Blackboard at live. So find our course, click Ted Live Collaborate. So this is our virtual classroom. So every day I log into the virtual classroom to make recordings. So in the future, if we have snow days again, you click this link to join the virtual classroom. Or go to our website. And this is also a link to our TED Live. If you don't have access to Blackboard, you can click this link to join. And then, okay, the recording. Click the menus and then click recordings. Then you can see all our classic recordings. Okay, so if you need it, send me an email. I can change the recording to public and create a link to send to you. Yes. Okay, so yeah, we continue. Yeah, and this was example 3. We didn't set the variable x, right? We don't need to. It's straightforward. And then example 4. Here, dimension. We set 2 variables, length and width. And look at all the sentence of the problem. Translate it into math symbol. Length is 2 times width, right? That's an equation. And then perimeter is add all the sides together. So 2L plus 2W, right, everybody? And then so here we have 2 equations, okay, and 2 unknowns. So we want to reduce the number of variables. Therefore, we plug in the L here so that we have one equation of one unknown. Then we can solve for it. And then we plug it back to find the L. This is if the area is 50 feet, square feet, and this is what you get. Okay? Do you remember that example? Okay. Yes. So I highly recommend you take notes during class, and then after class, review the notes, and then work on your homework. Okay? If you have questions, ask me. Or which step you don't understand, put a question mark, and then ask me. Okay. Yes. So last time we also talked about this problem. Speed is distance over time. Yeah. Oh, you know that from your physics. Yeah. And so here, from Portland to Topeka, we know the distance, we know the time. Therefore, we can find the speed. And because this entire trip, we have a constant speed. Therefore, okay, let's figure distance Portland to Atlanta. That's the distance. The time is distance over speed. Therefore, 4.52 hours. Okay, everybody? Now let's keep going. Example 6. You measure the shadow cast by Elm Center in Chicago. Have you been to Chicago? Yes? Okay. Have you go to the highest part building of yours in Chicago? Have you go to the highest building? The view. Okay, I happen to go. Yeah, maybe in the future we could do it. Okay, so shadow. Okay, so let's draw the picture. Picture help us to understand. So we have the building right here, the sun right here, and shadow. This is the shadow. And we find the shadow is 142 feet. Okay? And then we measure a 4-foot pole. So this is 4 feet, post, and find it. The shadow is 6 inch long. How many inch in 1 foot? 12. Yes. So 6 inch is 1/2 foot. Right, everybody? Okay. We want to determine the building's height. All right. Do you see we get 2 triangles, and they're right triangles, and they are similar, right? Similar triangles. What do we get? The ratio of the corresponding sides is the same, right? So what are we looking for? We're looking for the height of the building. So we're looking for the height of the building. Yeah? So the goal is to find the height. Let it be h. So the corresponding sides have the same ratio. Do you see h? What's the corresponding side? 4 feet, right? And then here, the corresponding side is this one. Yes, everybody? So we put h. The corresponding side is 4. And then 142. The corresponding side is, can I put 0.5? Is that 1/2? Yeah. Okay, so any questions about this setup? All good? Yes, similar triangles. Right. Okay. Now, how do we do? Oh, we want to find the edge. So you see the 4 here? Both sides multiply by 4 to carry out the 4. Then we have h equals 142.5 times 4. Yeah, we multiply by 4 on both sides. By the way, maybe it's better to put 1/2. You know, when we divide it by 1/2, it's the same as multiply by its reciprocal. So when you divide it by 1/2, it's the same as multiplying by 2. Exactly, right? So 142 times 4 times 2. So put in your calculator. What do you get? Thank you. Yes. And that makes sense because that number is bigger than 142. Yeah, the building should be so tall. So, yes. Okay. So, right, when you work with like the fieldwork problems, you check the work and see if it makes sense. Is your final answer a positive number? Okay, yeah. If you get negative number, right? Especially the time. The time should be positive because you're gonna go backwards. We don't have time machine to go backwards. And then here, you see, this must be taller than this. Therefore, it must be bigger than 142. Okay. Any questions about yes?
If you kept it as the fraction, it would have been 4 times 1/2. So wouldn't you have divided
This 1/2 is in the denominator. So when we cannot multiply by 4. This 4 is on the numerator. So therefore, because it's 1/1/2. This is actually 2. Okay? When you divide a number, it's the same as we multiply by its reciprocal. And then this 4 is actually in the numerator. Therefore, we get 8. Because it's in the numerator. Right? Yeah, we multiply by 4 on both sides. So this 4 is in the numerator. It's not in the denominator. So we cannot multiply by 1/2. Okay, good. Let's continue. Okay, so Our example 4, we talk about rectangle. How about other shape? So here we have two-dimensional geometry figures, and this is three-dimensional. So for two-dimensional, what do we care? We care about area and perimeter. So area and perimeter. Okay, so by the way, no formula sheets, right? So all of this, you gotta remember it. Okay, so square. Well, area. We know area is this side has this side. So that's why it's S squared. Right, everybody? Perimeter. S plus S plus S plus S. So 4 times S. Yes. Okay, and then rectangle. Area. Length times width. Perimeter. We have 2 length and 2 width. Yes. Okay, circle. Pi r squared. You all remember? Area of circle, pi r squared. Circumference. Yeah, we don't call it perimeter because circumference of the circle is 2 pi r. Okay, it's also pi times d, where d is the diameter. Yes. Okay, how about triangle? Well, okay, let me give you more. Okay, let me give you parallelogram. Let's do parallelogram first. So what is the area of a parallelogram? With base is B and the height is H. So area is, okay, you imagine we have a scissor, okay? And we cut this piece and paste right here. So you cut this pieces and paste right here. Do you see you get a rectangle? And then the rectangle area is length. Do you see the length is the B times width? Width is the height. So parallelogram area is base times height. Yes, everybody? And then perimeter. Oh, perimeter. Let's say this side is A. So perimeter is 2A plus 2B. This is for parallelogram. Now, triangle. What's triangle? Do you see? Okay, give me another copy of triangle. I flip it upside down. Do you see we get a parallelogram? So triangle is half of a parallelogram. Yes? Therefore, area, half of parallelogram area is base times height. That's why we get the half. Okay, everybody? And perimeter. Oh, we have 3 sides. Just add them up together. Okay, everybody? Okay, one more. Trapezoid. So trapezoid. So let's say this is trapezoid. We have A, B, and H. How do we find the area and the perimeter? Okay, so what we do is similar. We get another copy of the trapezoid and you put it upside down and paste here. Do you see you get a parallelogram? Yes? You get another copy, you put it upside down. Oh, we get a parallelogram. With this side, what's this side? Oh. A. This side? B. Oh, so this is A, this is B. Therefore, area of the trapezoid is 1/2 of the area of this parallelogram. Okay, so it's 1/2 of the area of this new parallelogram. Area of parallelogram is base, but do you see your base now is A plus B, and times height is H. Okay. Yes. So instead of memorizing the formula, I would say deduce the formula. How do you get parallelogram? Well, you cut it and paste it, you get a rectangle, right? How do you get a triangle? For half of a parallelogram, you get a triangle. How do you get trapezoid? Get another copy, put it upside down. You get a parallelogram. And how about a perimeter? Oh, let's say this side is C and D. It has 4 sides, so just A plus B plus C plus D. Okay, so those are all the two-dimensional geometry figures. Any questions so far? All good? You know how to derive it? Okay. Now, how about three-dimensional figures? We have cube. Ooh, cube. So S times S, and then times height. So actually, all the cylinder shape, you can think of cube is also a cylinder shape, but it's not circular cylinder. Okay, so in general, for cylinder, okay, so for cylinder, you have your base and then you have the height. So therefore, for base, let's say for cylinder, volume is area of base times height. This is true for all the cylinder. Okay, you might have this is a cylinder where your base is square. Okay, and this is a cylinder, your base is a rectangle. This is a cylinder where your base is a circle. But all of these you consider as cylinder. Okay, you can also have a cylinder look like this. So this is a cylinder where your base is a triangle. So all of this volume is area base times height. Okay, everybody? So, yeah, V is volume. Therefore, area base, that's the square, x squared, height is x, so x cubed. That's why we call it cube, x cubed. Rectangular solid, area base, length times width, and then times the height. Yeah, everybody? Circle cylinder, area base. See, circle, pi r squared times height. Yeah. Sphere, well, this one, we gotta memorize it. 4/3 pi r cubed. This is a formula. Okay, so no quick way to just memorize it. And what is also important? Surface area. So surface area. That's important. Let me call it SA. What is the surface area for a cube? How many faces a cube has? You roll a die. Yes, 6. And each face is a square, right? 6 face, each face is a square. That's why we have 6s squared. That is the surface area. How about for rectangle? Well, it has 6 faces, but the area are different. The front and the back are the same. Let's say they are width times height, right? So we have 2 width times height plus the left face and the right face. They are length times height plus the top face and the bottom face. So we have 2 times length times width. Okay? So top face, bottom face, 2 times length times width. Left, right, length times height. Front and back, width times height. 2 column lengths. So this is the surface area. Right, everybody? Mm-hmm. Yeah, take notes, and then after class, review your notes, review your homework. Okay, how about circular cylinder? Ooh, this is harder. Think about a Coca-Cola, a can. What's the material? How much material? How you want to make a can? Well, the top and the bottom, they're area of circle, right, everybody? So surface area, top and bottom circle. Yeah, 2 copy of pi r square, right? And what? So you have the top and the bottom. And then how about this side? You cut it and open it up. Do you see you get a rectangle? Imagine your can, right? Imagine your can. You cut it and open it up. It's a rectangle with the width is the height, and then the length is the circumference of the circle. Yes, the length is the circumference of the circle. What's the circumference of a circle?
2 pi.
Yeah, 2 pi r. Therefore, we get 2 pi r times h. Yeah, 2 pi r times h. That is the area of the site. And then for sphere, surface area is 4 pi r squared. Okay. The sphere you just get to remember. These ones you can look at the picture and deduce. Okay. So these are all the 2D geometry and the 3D geometry. Any questions so far? Okay. Other formulas. Temperature. Have you seen this temperature formula in physics? So we use Fahrenheit, but other countries might use Celsius. Yeah, you use Celsius? Do you translate into Fahrenheit? Yeah. China also use Celsius. So the first 2 years I came to the US, I was confused. What does 75 mean? Is it hot or cold? So I have to translate to Celsius and to okay. So Fahrenheit is 9/5 times Celsius plus 32. Okay. And in China, we use meters. Okay, and we use kilograms. And then when it comes to the US, I figure out pounds is not a mass unit. It's a force. And the mass unit is flux. Yeah. Mm-hmm. Right. Okay. So that is the temperature formula. Simple inches. Inches is the principal times the interest rate times the time. Have you seen this before? The simple interest formula? The principal times the interest and then times the time in years. How about compound interest? Have you seen this before? We have the principal. Let's say your annual interest is R, and then you're doing N compoundings per year. Let's say if you compound monthly, what's N? How many months in a year? 12. Yes, so we have 12 is N. If you compound quarterly, how many times you compound per year? Quarterly. How many quarters? 4, exactly. Yeah, everybody? Okay, so this is a formula. We will see this problem more in the chapter when we introduce exponential function. Okay, so right now, don't need to worry about compound interest. Just focus on simple interest. This is speed times time. Yeah, this one we know. Okay. You invest a total of $10,000 at 4.5% and 5.5% interest rates. During 1 year, the two accounts earns $508.75. How much did you invest in each account? Okay, so set the variable, let X be the amount invest in the account with, let's say, 4.5% interest rate. That's x. Okay. And then you have a total of 10,000. You invested x in this account. How about the other account? The other account is the rest of the money, right? So your total is 10,000. You put x here. For the left is 10,000 minus x, right? Everybody? Yeah. So let's say, so 10,000 minus x is the amount invested in the account with 5.5% interest rate. Yeah, to say if this sentence is almost the same, you can put that account to save you some time of copying. Okay. Does that make sense? We have total of 10,000. You put x amounts here, and then the rest is 10,000 minus x. Yes, everybody? Okay, now what is the interest? Oh, interest. So we have two accounts. The first account is x times the interest rate, which is 4.5%. So when you are doing your work, be careful. The dot in the middle means multiplication, and this is the decimal dot. Okay, this is the first account. And because we're doing 1 year, that's why you multiply by 1 year, then it's like nothing, right? If you're doing 2 years, then you gotta multiply by 2. Plus the other accounts, the principal is 10,000 minus x. And the interest rate is 5.5%. Oh, that is interest is principal times interest rate times time. Okay, so interest is principal and times interest rate and times time. Because the time is 1 year. So that's why we don't multiply anything to it. The formula is right here. The simple interest. Okay. And the interest of the two accounts is what? $508.75. So far, so good, everybody? Okay, we're gonna calculate it. What is 4.5%? 0.045. Yes. So 0.045. And usually, when you multiply x and the number, you usually put the number in front of x. That's usually what we do. Do you think so? Yeah. Usually we see something times x, we put the number in front of it. Okay, now, and then this is 10,000 minus x. What's 5.5%? Yes. Okay, keep going. So 0.045x. Okay, use 0.055 times 10,000. Well, that's the same as we move the dot 1, 2, 3, 4 digits. Yes, everybody? So we get 550. Yes. This number is easy, so we just get it. If we have a more complicated number, you can use your calculator. So when with this problems, you can use your calculator because the number is usually hard. Okay, and then minus 0.055x equals the right hand side stay the same. Right, everybody? Okay, and then we combine the like terms. What is 0.045x minus 0.055x? What do you get? Yeah, very good. Okay. Now, oh, I don't have enough space. Let me let me move this top a little bit. Okay. So this is the good thing about Word. I can shrink it and I can move it. Yes. Okay. So, all right. And then we also moved 550. So we get negative 0.01x. What is 508.75 minus 550? Negative 41.25? Oh, yeah, 42.75? Mm-hmm. So, okay, let's do it slowly. So this is like negative 550 minus 508.75. Therefore, it's negative. 5 and 5 cancel. And 50 minus 8.75 is 41.25. Right? Okay, use your calculator. So 508.75 minus 550. Yeah? Yes? Mm-hmm. Okay, now get the x. Both sides divided by, okay? Both sides divided by negative 0.01. What do you get? So we have, oh, do you know negative cancel? Right? Yes, negative cancel. Do you know when we divide it by 0.01, it's the same as multiplying by 100? Yeah. So we multiply by 100. It's like you move the decimal, 2 digits. So we get 4,125. Later. Okay, that's your X. So we put that much money in the first account. How about the other account? What's 10,000 minus 4,125? 5,000 what? 5,875? Yes, okay. Right. So then we finished this example 7. Okay. Yeah, so this problem, more math, more algebra. So you gotta be careful because it has decimals and the minus sign. You end up getting a number is possible. Okay? You'll get negative numbers. So check it out. Okay? Any questions about this problem? Are we all good? Okay. Let's see. Example 8. The cylindrical can with the base radius 4 centimeters. So cylindrical can. So it's a circular cylinder with the base radius. So R is 4. Has a volume. The volume. So radius is 4. Volume is 200 cubic centimeters. Find the height of the can. Okay, so find the height. What is the volume formula for pi r squared times height? Yes, everybody? That's why we're gonna familiar with all the geometry figures. Good. Now we plug in the numbers. What is B? 200. Pi is pi. What's pi? 3.1415. Yeah, something like that. R, what's R? 4. Yeah, and we are looking for height. So both sides divided by what? Pi and 4 square. Right, everybody? Okay, so plug in your calculator. What's 200 divided by pi and 4 square? What's 4 square? 16, yes. 3.97, great, centimeters. Yeah. Okay, good. Oh, what's your next digit? What's your next digit? 3.97? 8? Yeah? If your next digit is greater or equal to 5, what do? Round up, yes. Okay. So if you don't remember, if the next digit is less than or equal to 4, we round off. If the next digit is greater or equal to 5, we round up. Okay, everybody? That's we round numbers. Okay, last one. Average temperature in Fort Wayne is 50.35 Fahrenheit. What is this temperature in Celsius? Okay, what's the formula? Fahrenheit 9/5 Celsius plus 32. Fahrenheit 9/5 Celsius plus 32. Fahrenheit is 50.35 Celsius. We're looking for that. So what do we do? Subtract 32. What is your left-hand side? 18.35. Right, everybody? Okay, what is C? What do we want to do? Yeah, very good. So 18.535 divided by 9/5. Do you know divided by 9/5 is the same as multiplied by its reciprocal? So you are multiplying by 5/9. Yet when we divided a number, it's the same as multiplied by its reciprocal. Okay, so that's why I'm afraid when you plug in your calculator, if you want to put 9/5, you need parentheses. Okay, otherwise you're instantly wrong. So use 18.35 divided by 9, but then multiply by 5. What do you get? What do you get? Thank you. Yes. So this is Celsius. Okay. All right. Have a nice day. I will see you on Wednesday.
Right.
Oh.